In this video, we're going to talk about radical functions. A radical function is a function where there are variables under a radical. Now, I've given a couple of examples of radical functions here and here. The example that is on the left is an example of what is called a square root function, and that is a function of the form f of x is equal to the square root of x. The example to the right is an example of what is called a cube root function. That's a function in the form of f of x is equal to the cube root of x. All right, so let's take a look at the graphs of the square root and cube root functions. Now, I did a very basic example of plotting the square root function. For the x values, I wanted to pick perfect square roots. For instance, I know the square root of 0 is 0. That's an easy point to plot, 0, 0. I picked 1 because the square root of 1 is 1, and our ordered pair here is 1, 1. Square root of 4 is 2, so the ordered pair is 4, 2. And the square root of 9 is 3, which is the ordered pair is 9, 3. And you can see 0, 0, and 1, 1, and 4, 2, and 9, 3. This is a square root function graph. Okay, so now let's take a look at an example of another one. Now, if you notice the values that I pick over here, again, I'm trying to pick values so that when I plug them in, it's going to be a nice number under the square root. For instance, I know 1 minus 1 is going to be 0, and I know what the square root of 0 is going to be. 2 I picked because 2 minus 1 is 1, and the square root of 1 is 1, so on and so forth. So let's do these particular values now. Okay, so when I plug in 1 minus 1 is 0. The square root of 0 is 0 times 2 is 0. Minus 1, that's negative 1. Plugging in 2 minus 1 is 1. Square root of 1 is 1. Times 2 is 2. Minus 1 is 1. Plugging in 5 minus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. Minus 1 is 3. And then 10 minus 1 is 9. Square root of 9 is 3. Times 2 is 6. Minus 1 is 5. Okay, so I've changed this from a y to g of x because it's a function and not an equation. So let's graph these 4 points now. So again, looks very, very similar to the graph that we just saw a minute ago. Okay, now let's take a look then at a basic cube root function. Now again, I tried to pick perfect cube roots. For instance, the cube root of negative 8 is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. Cube root of negative 1 is negative 1. So I've plotted these 5 particular points here. Okay, the last thing I want to talk about in this video is the domain of radical functions. Recall, when the index is even, a negative number under the radical is not a real number. So for instance, the square root of negative 16, that's not a real number. Or the fourth root of negative 16 is not a real number because there's no number times itself that's going to give me a negative 16. Or a number times the same number times the same number times the same number to give me negative 16. But the square root of 0 is 0, and the square root of 16 is 4. Those are both real numbers because 4 times 4 is 16, and 0 times 0 is 0. Now, when the index is odd, you can have a negative number, a positive number, or 0 under the radical. For instance, the cube root of negative 8 is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. Cube root of 0 is 0, and the cube root of 8 is 2. Because of these little rules here for the indices, in general, here's what we can say. If the index of a radical is even, then the radicand must be greater than or equal to 0. If the index of a radical is odd, then the radicand can be any real number. Okay, so let's write the domain of each function in interval notation. So this example right here. Now remember, if you don't see a number for the index, you assume it's 2. Because 2 is an even number, what am I going to do? I'm going to take what's inside the radical and set it greater than or equal to 0. Subtract the 7. Now, remember, when you divide by a negative number, you must switch the inequality sign. Negative divided by a negative is a positive. So, on a number line, if this is 7/3, okay, I would be shading to the left. Well, how do I write that in interval notation? Well, this represents negative infinity, so parentheses, negative infinity to 7/3. 7/3 is included, so I would write a bracket after the 7/3. Okay, let's take a look at this example here. This time around, the index is odd. Well, because the index is odd, the radicand can be any real number. Well, how do I write that? Well, I'm going to write the domain is equal to negative infinity, comma, positive infinity. Now, that could be the 5th root, could be the 7th root, could be the 9th root. It does not matter. The domain is always going to be negative infinity to infinity if you're asked to write it in interval notation. All right, let's take a look at the next example then. Here, the radicand is in the denominator. Now, the index is even, so automatically it's going to be greater than or equal to 0. But because a square root is in the denominator, it cannot equal 0. So what I'm going to write then is I'll write x minus 3. But instead of it being greater than or equal to 0, because remember it can't equal 0, I'm going to write it as strictly greater than 0. So add 3, x is greater than 3. So on a number line, if that's 3, I can shade to the right. How do I write that in interval notation? Well, I can't include 3, so that's a parenthesis 3, comma, infinity. And I'll have a parenthesis after the infinity. All right, one other example then. This time around, I have a cube root in the denominator. Well, if the index of a radical is odd, then the radicand can be any real number. The problem, again, similar to the last example, the radicand is in the denominator, so it cannot equal 0. Well, what am I going to do? I'll set this equal to 0 so that I can get rid of the restriction. So add 3 to both sides, that's x equal to 3. Notice I can be any real number, so I can have an open circle at 3, but I can be any value that's less than 3, or I can be any value that is greater than 3. Well, how do I write that in interval notation? Well, that represents what? Negative infinity, and I go to 3. But because I cannot include 3, that's going to be a parenthesis. That takes care of the left side. The right side, it's separated, so I'm going to write the U for union. Again, I start with 3, but I cannot include 3, and I go all the way to infinity. So in other words, the domain is all real numbers here except 3.